Greetings, Mr. Sutton here with the AB Calculus 4.1 Extra Practice Number 4 solutions on extreme values of functions. On this problem, we're trying to figure out the x value where we hit a minimum value for this 3x to the 4/3 minus 2x function on the interval 0 to 1. So we know that we're going to have to test 0 and 1 out, at least if we're using the candidates test. And we're also going to have to test out any critical values we reach on that interval. Let's find those critical values by taking the derivative of this expression. So that's going to be, let's see here, using the power rule, we have 4/3 times 3. That's going to be 4x to the 1/3 minus derivative of 2x is 2. And we're going to set that equal to 0 and solve. So let's see here. If I add 2 and divide by 4, I've got the cube root of x equal to 1/2. Which means that if I raise both sides to the third power, x is going to be 1/8. Now 1/8 is on the interval from 0 to 1, so it counts. It's a candidate. We got to test it. Going through and testing each of those now, let's start with 0. That's an easy one. Plugging 0 in here, that just gives us 0 back from the original function. And plugging in 1/8 now. To do this, I'm going to rewrite this part of the original in radical form. So this is going to be 3 times the cube root of 1/8 raised to the 4th power. And then we also have minus 2 times 1/8. So for this first expression, cube root of 1/8 is 1/2. To the 4th power is going to be 1/16. So that's 3 over 16 minus 2 over 8. I could reduce it, but you'll see why I don't here, because I'm going to need a common denominator to figure out what happens if I subtract these. This is really 3 over 16 minus 4 over 16, which is going to give us negative 1/16. Okay, so let's also plug in 1, the other endpoint. And doing that, we just end up basically with 3 minus 2, which is 1. So out of all of these, the only negative number is that critical value, which means that the x value we're looking for is 1/8. Which would be choice B. For this problem, we're given this f function, x plus 4 over x minus 1 times x plus 3, and the closed interval, negative 5 to 5. We want to know on which of these closed intervals here is this function guaranteed by the EVT, Extreme Value Theorem, to have an absolute max and min. So just to review, the EVT says you're guaranteed to have absolute extrema if you have a continuous function on a closed interval. So taking a look here, well, we've got a closed interval, so it's really the continuity that's an issue. We have discontinuities for this function at x equals 1 and negative 3 because those zero out your denominator. So let's just take a look at the answer choices because we can quickly eliminate any answer choices that contain negative 1 or 3. So choice A, negative 3 and 1 are both contained in that interval, so choice A is no good. For B, those are the endpoints. So within those endpoints, there's no discontinuity, but because the endpoints don't exist, that doesn't really count as a closed interval or continuity across the whole interval anyway. Choice C, negative 3 is not in there, neither is 1, so C is looking pretty good so far. And then choice D, 1 is contained between 0 and 5, so that's no good. So out of all of these, only negative 2 to 0 has no discontinuities, so only choice C then is going to be guaranteed by the EVT to give us mins and maxes. On this problem, we're given the function f as x times sine of x with a domain of 0 to infinity, and we're told that there's no absolute min and max on the domain. Why does this not contradict the extreme value theorem? Well, first we have to remember what the extreme value theorem says. It says that if your function is continuous and it's a closed interval, which the EVT requires both of these, then we're guaranteed to have an absolute min and max. And yet we don't have one. So which one of these conditions is being violated in this problem? So the function here, x sine of x, is continuous. X is continuous because it's a polynomial. Sine is also known to be continuous. Multiplying continuous functions together gives you another continuous function, because where would the discontinuities come from if everything matches up and has a value? So we have a continuous function, So it's really the interval that has to be in question. Taking a look at this, we're going from 0 to infinity. That is not closed. Infinity is wide open. So out of all these answer choices, the main issue is B, the domain of f is not a closed and bounded interval. Looking at these other answer choices, though, choice A, domain of f is not an open interval. Actually, it is. That's the problem. The function is not continuous. It is. Function is not differentiable. Well, EVT doesn't really talk about differentiability, but this is also a false statement, because if you think about it, you just have to be able to take the derivative of this thing and have that derivative exist at all values, which it does. So choice B then. For this problem, we're given a polynomial and asked what the absolute max on the interval -3 to 1 is. Probably the quickest way to do this is just to use the candidates test. So we have to plug in the endpoints here and also any critical values that we find. Let's go ahead and find some critical values. We're going to take f prime of this thing and set it equal to 0 to find those. So the derivative, that's going to be 6x squared plus 6x, just using the power rule here. And that 1 just goes away. That's 0 if you take the derivative. So let's set this equal to 0. Now to solve this, we can factor out a 6x, leaving us with x plus 1. And this equation is solved at x equals 0 and also -1. So these numbers are both inside the interval that they gave us. So we also have to test these. These are also candidates. So going through and testing each of those values now in the original function, let's try f of -3 first. And we have to do all this without a calculator. This is a no calculator question. So mental math or write out your work. So first off, we've got -3 cubed, which is -27, times 2 is -54 for that first term. This next one is going to be 3 times 9, so 27. And then we have a plus 1 at the end for all of these. So this is, let's see, -27 plus 1 is -26. All right, well, that's not a very good candidate for absolute max, but if all the other ones are more negative, it might be the winner. We never know. So let's go on to the next one, -1. Plugging that in, we have 2 times -1, so that's -2. 3 times 1 is 3. We have a plus 1. So -2 plus 4 is going to come out to 2. So far, that's the winner. On to 0. Plug in 0 in. Well, that's pretty easy. We just get 1, the only thing that doesn't have an x. And then finally, plugging in the other endpoint, +1, also pretty easy. This is going to be 2 plus 3 plus 1. So that's going to be a grand total of 6, which is the absolute max here. So that's going to be choice C. For this problem, I'm trying to find absolute min for sine of x plus cosine of x on the interval from 0 to 2 pi. To start this off, I'm going to find some critical values. So f prime, set that equal to 0. That's going to be cosine of x minus sine of x. And let's see where that equals 0. Solving this is a little bit tricky, especially because we're not allowed to use a calculator on this one. But you can do it by adding sine to the other side and then dividing both sides by cosine, which is legal because these can't both be 0 at the same time since you're on the unit circle, not the origin, which means that neither of them can be 0. So dividing both sides by cosine, we end up with 1 equals tan of x, because sine over cosine is tan of x. And then inverse tan, tan has a slope, the angle has a slope of 1 between, let's see, 0 and 2 pi at 2 places. Pi over 4, or 45 degrees, and also kitty corner 225, which is 5 pi over 4. So little unit circle knowledge helping us out on this one. So we have a couple critical values, and these are both on the interval from 0 to 2 pi, so they're both candidates. We're also going to have to test out 0 and 2 pi, the endpoints. Those are always candidates when you're looking for an absolute min or max. So let's go and test each of those out in the original function. So f of 0, that's going to be sine of 0, which is 0, plus cosine of 0, which is 1. So that's 1 overall. And now f of pi over 4, that's 45 degrees. So sine of that is root 2 over 2. So is cosine. So we have radical 2 over 2 plus radical 2 over 2. Well, if I have half of a radical 2 and another half a radical 2, that adds up to a whole radical 2. And let's see here. Let's try out 5 pi over 4, 225 degrees. This is essentially the quadrant 3 version of 45 degrees. So it has the same values as sine and cosine of 45 degrees, but they're both going to be negative because x and y values are negative in the third quadrant. So we end up with cosine, up here, sine of 225 is going to be negative root 2 over 2. Same thing with cosine. And this is essentially what we had up here, but just a negative version of that. And then finally we have f of 2 pi. So sine of 2 pi is 0. Cosine of 2 pi is 1. It's really the same as when you plugged 0 in. It's coterminal with 0. So that comes out to 1 again. Now out of all of these, we're looking for the smallest one. And the good news is, I mean, this is an easy decision because there's only one negative value out of all of these, so it must be smaller than the other ones. Negative radical 2 is our absolute min, which gives us answer choice B. On this problem, we're trying to find the absolute max for this g function here on the interval from negative 4 to 1. So we're going to use the candidates test, especially since we don't have a calculator. So we're going to test negative 4 and 1, the endpoints, no matter what. We also need to take the derivative of this thing and find critical values because those might be candidates as well. So for the derivative, I'm going to use the product rule, u prime v plus uv prime. And here's my box and ribbon to help me organize that. I've got my first factor, this parabola here, x squared minus x plus 1. And then e to the x is my other factor. Derivatives of those, we've got 2x minus 1 and e to the x. And I'll just multiply all that out now. So we have 2x minus 1 times e to the x, plus this whole thing in a parentheses times e to the x. And we need to figure out where this takes on a value of 0. In general, with critical values, you also need to look to see where the derivative is undefined. But since we have polynomials and exponentials, we're not going to be able to make this undefined anywhere. So this is really just going to come down to where it equals 0. Now, to help us with this, we can factor an e to the x out of this. And if I do that, I've got 2x minus 1 plus, well, x squared minus x plus 1. I'm just going to combine some like terms and stick them in a parentheses next to the e to the x. So I have an x squared. There's no other terms to combine with that. 2x minus x is going to be just x plus x. And then these 1's are going to cancel. So I just end up with x squared plus x, and that all still equals 0. To get a little further on this one now, I notice that I can factor an x out of this parentheses. So I'll have an x, an e to the x, and an x plus 1 when all is said and done. Now, e to the x, there's no way you're ever going to get to 0 that out. But we do see that if we plug in 0 for x or negative 1, we can 0 out that equation. So those are going to be our critical values. Now, taking a look at where those fall, they are between the endpoints negative 4 and 1. So we do have to test them. So at this point, we're going to plug all 4 of those candidates into g of x. I'm going to start with the most negative, negative 4, one of the endpoints. Plugging that in, we've got negative 4 squared, which is 16. This will be a plus 4. We have a plus 1. And e to the negative 4, I'm going to write that as 1 over e to the 4th. So this comes out to 21 over e to the 4th, which I'm not really sure how big that is. E to the 4th is probably bigger than 21, so at the very least, this is most likely less than 1. But beyond that, I have no idea, because it's not a calculator problem. Let's move on to the next value. That would be negative 1. So plugging that in, we've got positive 1, plus 1, plus 1. So this is a tough one here. We have e to the negative 1, which is 1 over e. So this is going to give us a grand total of 3 over e. Now, 3 is definitely bigger than e, because e is 2.7 and some change. So this is bigger than 1. So right now it's looking like 3 over e is our winner. But let's keep going. So our next value we'll try is g of 0, the other critical value. That's going to be, let's see here, 0 minus 0, still 0. So we have 1 times e to the 0. e to the 0 is 1. 1 times 1 is just a grand total of 1, which is smaller than 3 over e. So far it's looking like 3 over e is our winner. We have one more to try, though, the other endpoint, g of 1. So g of 1, that's going to be 1 minus 1, which is 0. So we have 1 for that parentheses, times e to the 1, so that all comes out to just e. E is far and away bigger than any of these other values. It's not that big, it's 2.7 and some change, but it's definitely bigger than 1, bigger than something that's a little bit bigger than 1. So this is going to be our absolute max, giving us answer choice B.